Hello and welcome back to PIC Aviation ATPL Tutorials, and today we're going to be looking at some more GenNav. So the question at hand is: a route is flown from 80 degrees south, 100 degrees west to 80 degrees south, 140 degrees east. At 160 degrees east, the grid track and the true track on a polar stereographic chart with the grid orientated on the 180 degrees meridian are respectively. So first of all, what I'm going to do is I'm going to make a point 1, highlight, because I like to do these quite in a very methodological fashion. So highlight, first of all, are flats and longs. 80 degrees south, 100 west, 80 degrees south, 140 east. Our midpoint 160 degrees east, that's where we're going to look at what the grid track and the true track are doing. So grid track and true track. It's a polar stereo, and the grid is orientated on the 180 degrees meridian. So 2, diagram. So I'm going to start, I'm going to draw a circle to represent our Earth. It doesn't have to be anything to the standard of Lowry or anything like that. Centre, we mark, we look to see what hemisphere we're in. It's clear we're in the southern hemisphere. Because we're in the southern hemisphere, if we think about it, our true north is going to point from the South Pole here up towards the North Pole, go past the equator and then up to the North Pole. So we can mark that on like so. If it was the North Pole, we'd obviously point to that point, the North Pole obviously. So the next point is to start drawing in our longitudes. So first of all, let's draw in 140 degrees east. It's probably about there, isn't it? Then going to draw in 100 degrees west. So I've done them the wrong way around, but it doesn't matter because it's all going on the same place. There's 100 degrees west, I can mark it off. I can also mark the angles. That's obviously 140 degrees. That's obviously 100 degrees. That leaves us with 120 degrees. And that's just by simple addition of 100 and 140 and subtracting the sum of 240 from 360 to get 120. The next point is to draw a line between the 2 points, going just outside of them, just so it makes it nice and clear. And there we go, we've got Legionite colours going on there. So with that said, we can now draw in 2 more things. The first being our midpoint. Midpoint, or as it says here, the point at which we're going to measure our grid track and true track, which is 160 degrees, which by thinking about is halfway. So we can draw that straight out there, halfway, and we can mark it off as 160 degrees east. There's one more thing we can draw in, and that is the Greenwich Meridian, which we're referencing to. So we can draw that down like so. 180 degrees east, west. We can also draw that here and here, just to help us with our grid navigation. So we know that we've got our true track reference to true north and our grid tracks reference to grid north, here and here. So you can see now that the diagram is getting a bit busy, but it's nothing to worry about, and we can work out the answers simply from this. So we've split the triangle in half there. That should be quite clear. Because of that, we have 120, and obviously we've got 2 angles here. Angle sum of the triangle is 180. 180 minus the 120 in the middle leaves us with 60. So there we have 30, and then we have 30. As I said earlier, we have split this triangle with this red line at the 160 degree meridian. So we can also say that that's 60 and that's 60, meaning that these angles in the middle are going to equal 90. So that's 90, that's 90, that's 90, and that's 90. That's very helpful. That's referenced to 160 degrees east, i.e. our true north, along that meridian. We're trying to work out the true track and the grid track. Well, at 160 degrees east, the true track is going to be measured clockwise from true north. So what we can do is turn around the paper and we can say, right, what direction are we travelling in? Well, turning around again, we know we're travelling from 100 west to 140 east. There's 100 west, there's 140 east. So we're going to continue travelling west. Don't be confused thinking it's east. We're going to keep going west because that'll be the shortest way around the globe. If you've got a globe around at home, have a look and check, and it'll help you see that. So we can mark this, we're going that way, west. So thinking back, I can draw it there also. We know we're going this way. So we're going to reference, measure from true north on this meridian track. So it'll be round like that. And that gives us 360 minus that 90 there, because it's 90 degrees shy, a right angle shy of a full circle, a full 360. So we know, therefore, this angle here, and I'll mark it, is 270 degrees true. So our true track equals 270 degrees true. But we now need to work out our grid track. Now, looking at this, our grid track is going to come off towards 180 degrees grid down here. Because of that, it's going to be turning around again, working it out. We're going to reference it from not true north, but grid north. So it's going to be, and excuse how large that looks, it's going to be that angle. So you can see there's a little bit more. That angle there, so it's 270, and add that little bit there. Now, the difference, I'm going to put the difference as a triangle between grid track and true track is convergency. Now on a polar stereo, on P.S, conv equals chlong, the change in longitude. And the change in longitude between 180 degrees west and east, the antimeridian, and our reference of 160 degrees east is obviously just 20 degrees. So the difference between our true track and grid track is 20 degrees. And the point now is, do we add, do we subtract? Well, turning around again and thinking back to what I've just said, that's 270 marked in red. With the green reference to grid north, it's a little bit more in it. So it's obviously going to be 270 plus 20. And therefore, we can say that grid track equals 270 degrees plus 20 degrees equals 290 degrees. And just for nice clarification, we can say our true track equals 270 degrees true, and our grid track equals 290 degrees grid from what we've worked out. And you can say that's because convergency being equal to the change of long on a polar stereographic chart. So that concludes this tutorial on polar stereographic charts and grid nav. Look out for some more videos coming soon.